taking the video camera around, videotaping rides. A lot of the analysis of the data that we do is with the video camera. So let me just show you this. This is the way I highly recommend you try at least once, just because you're going to be doing so much of this at Oaks Park. So what you do is you say insert video capture, okay, and it will say USB video camera. Oh, look at that. It's got two cameras plugged in, but I don't want the AverVision. I want this camera. And I don't know. Try 320 by 240. Let's see if you can handle that. So basically, if you crank the resolution up too high, the USB will chunk because it's not really that big a bandwidth. Definitely, you cannot stream full motion 720 video through it, but it should be able to handle this. Do not use, let's see, has made an attempt to load. Should we try don't use? You think?
No. Just this one, maybe? Just this one. Just this one.
There we go. This is good. There we go. Shabika is very happy. There we go. Isn't that beautiful? Okay. And what Shabika is going to do is she's going to go like this with her hand, go back and forth. Okay, here we go. So we're going to start the capture. Keep going back and forth. And we're going to stop the capture. And we should have a little video popped up. There it is. Okay. Okay. And then this is, we're not going to do a good job of this. So you're going to do this. You're going to make a collision happen on the camera, right? And then what you can do, and this is a very cool thing, there's tools that pop out there. And I can expand this. I can't make the video higher resolution, but I can expand it so it's a little easier to click on things, right? There she is. She's looking up at the camera, right? And the first thing we can do is we can go in here and I can't remember which one it is. Is it this one? I think it's this one. Is that usually it's got a little thing that tells me what it is. We'll see if this is the right one. Okay, that binder right there is 13 meters wide. Isn't it? 13 meters about? I'm just kidding, right? So the key here is that you've got to have some object. The reason why that binder is not a great thing is that it's tilted with respect to the camera, so its apparent size is smaller than its real size, right? But when we do the video capture, we're going to have a meter stick sitting there with the camera that it can look at, right? And so what we do now is we've told it that this thing is 13 meters long, which is ridiculously large, right? Okay, and now it's calculating the size of everything in that screen, but it's assuming that everything's the same distance from the camera because it has to, right? Okay, so when we do this, our meter stick is going to be the same distance as the carts or whatever. And now we can go in here and if we wanted to, we could straighten out the picture, but we're going to set up so we don't have to. Now I can gather data. So let's click on her hand. Okay, and she's not moving her hand. Now it's moving. There it is. Okay, and what we're deriving from this is it's assuming that this binder is 13 meters wide, so these values will be like just crazy, right? Okay, but it's basically set up a coordinate system. This is 0, 0, right? This is probably 26 meters out here because it's like 2 binder widths or something like that, right? And it's going to put in a data table the positions that I've been clicking on here, right? And you got to pick the same thing to click on, right? Okay, it's putting those positions into a data table. Isn't that fun? Isn't that fun? Wow, that's a big hand you've got there, Shabika. Okay, Okay, so let me show you this in actuality. Let's delete this. Let's go data, clear all data. Let's insert a movie. You can just insert movies that other people have made. So let's look at our desktop here, demos, movie capture. Oh my gosh, this just happens to be a couple gliders colliding. Look at that. Okay, let's find a shot where where I get out of the way, and there we go. Now we can see the whole meter stick. Okay, so let's tell it that that's a meter, right? So I'm going to click on this, and I believe it's that one, right? I'm going to tell it that this is a meter. Yeah? Oh, that's pretty good. And it guesses, by the way, that it's a meter stick because it's got like shape recognition software in there. Either that or it always guesses a meter, one of the two. Right? So that's a meter. Now we're pretty accurate, aren't we accurate? Yeah, there we go. Now I want to find where the collision occurs, and it's happening like right there, isn't it? Yeah, cha-cha-cha-cha-cha-cha. Okay. Okay, so that's pretty good. And now I'm going to pick this edge to click on. And all we really care about is the x values. If it moves too slowly, one of the tricks you can do is instead of pointing at it with the crosshairs, the center of the crosshairs, you can use the top or the bottom of one of the crosshairs. Is that enough? That's probably enough. Isn't that enough? Okay. So let's move that out of the way. And all we really care about is the x velocity here. See the x velocity? See it? See it? There we go. Okay, so let's copy. If I copy, does that do it? Let's try it. Okay, let's paste it in here. Oh, there it is. Okay. Okay, which one's which? This is time, isn't that right? Time x, y, x velocity. So is it the fourth column that we want? Is that right? Fourth column. So 1, 2, 3. We want this column here, correct? So let's go edit, delete, delete. There we go. And we don't really care about this guy. Y velocity is just me moving the cursor up and down, right? Okay. So let's see what this looks like just really fast. You don't have to graph it. I'm just graphing it for fun. There we go. Here's before, here's after. Yeah? Do you see that? Okay. So this is going to be the momentum before the collision. This is the momentum after the collision, right? Or the velocity after the collision. And so it looks like to me like the collision's starting to occur at 3.4833, right? So all of these guys are before, don't you think? Or certainly safely these guys are, right? Yeah? These are safely before the collision, yes? Okay. So I want to average those guys. Is there an way to average it? Come on. I wish there was like a button I could click. Auto sum. I could do an auto sum. No, I don't want to do that. Okay. I'm just going to say equals average. I wish there was like a button I could click, right? Oh, there we go. These guys, right? Or these guys? For sure those guys, right? Okay. So there's my velocity before the average, right? And then afterwards, for sure by the time we get to 3.655, it's after the collision, right? So that's here, 3.655. Where is that? There it is, right there. This is definitely after the collision, right? Okay. So I'm going to say equals average of these guys, yeah? Okay. Okay. How do I get the uncertainty for this one? Do I just do max minus min over 2, right? Is there a way to do that with Excel? Do you suppose there is? Yeah, maybe. Okay, what is this? This is 11 through 19, right? Okay. So it's going to be plus or minus. It was 11 through 19, right? So it's going to equal parenthesis max. There's a function called max, right? 11 through 18 minus min. Do you suppose there's a function called min? Divided by 2. Did I do it right? There we go. So there's your uncertainty of that guy, right? I can do the same thing here. I can go equals parenthesis. And what is this guy? Oops, I'm in trouble. That is 1 through 6, right? So equals parenthesis max of 1 through 6 minus min. Minba. Minba. Ah, Minba. Yeah? There we go. Okay, so those are the 3 ways that you can do it. If you want to do it more than one way, that's fine. I could give you extra credit for that. Okay,